So we're starting off with just a little unit circle practice here. And I asked the kids to find cosine of 3 pi over 2. So, well, here's where 3 pi over 2 is. And cosine is the x value of it. So 0. Raise your hand if you had that one right. Cool. Now, do you get, if you had this memorized, that it would make it go pretty fast? Now, you still wouldn't have it on a page like this. I mean, that would be really, really nice. See how fast you can do this. What is sine of 3 pi over 4? You see it? Sine of 3 pi over 4. Lucas Brahma, what do you think? Sine of 3 pi over 4.
3 pi over 4 is negative square root 2 over 2, right?
Sine is the y.
Oh, so then square root 2 over 2.
Okay, so there you go. And this is the cosine of it. And tangent. Tangent's a bit of a pain on these. But since they're the exact same thing, do you get if I'm going to take this divided by that, y divided by x for tangent of it, it would just be -1. Yeah. All right. Okay. So, do I expect you to memorize it, though? No. And one of the reasons is that if we change the problem to be sine of some angle comes out to be 1/5, then your unit circle is useless. Okay? I'd like you to draw this situation for me, and there's an appropriate question for you to ask me right now. Like, you need more info. What do you need to know? Yes? Exactly, because there's two different quadrants. You should have been thinking, well, Mr. Server, do you want it in the A or the S quadrant? Because both of them would be positive 1/5. All right. If there was a variable, remember yesterday, if there's a variable, always do it in the first quadrant. But if there isn't, then you have a choice of two places. All right, so let's put this in quadrant 2. Still, you don't know what I want. Like, I haven't told you what to do other than you draw your triangle, which I know many of you are dutifully drawing your triangle, and this is awesome. Sine is opposite over hypotenuse, and then I can figure out the third side. But if I just wanted the angle, you wouldn't have had to draw any of that. Do you get? You could have just done the inverse sine of it, and you would have had the angle, but you need a calculator. Do you get? I could just do inverse sine on both sides. Inverse sine here, inverse sine here, if I wanted the angle. But do you think we would do that on the test? No, because I'd have to give everybody a calculator, and it would be pretty easy and dumb. So, no, that's not what we would do. What we would do, though, is ask you, why don't you tell me, what do you think the question would be?
What's the cosine?
Exactly. What's the cosine or what's the tangent of the angle? All right, so let's do cosine of theta equals what? Davis, can you tell me what that third side has to be?
Is it square root 24?
It's for sure square root, and then 25, and then a 1. And how do you know what to do with them?
I subtracted the 1 because you already have the hypotenuse. So
Yeah.
you find the other shorter side.
On the longest side, you would have added, but this isn't the longest side. All right, good job. So square root of 24. Do you think it'd be wise to simplify square root of 24? Yup. You could lose points for leaving it as square root of 24. So take a second if you haven't already and simplify that. And then that's going to be, well, I like to leave them at 2 square roots first. Just keep on breaking it up a little piece at a time. And then that's 2 root 6. You guys got 2 root 6 for that? Okay, now what's the most common mistake in circle trig? Negatives. There's a negative on it. And last but not least, cosine is adjacent over hypotenuse. This side right here is the adjacent side over the hypotenuse. So -2 root 6 over 5. Other than the negative, how many of you would have had that one right? Okay, good. All right. So that's yesterday, except the other thing from yesterday was, what if I give you an x on one of the sides? So let's do one of those. cosine of some angle is x over x plus 1. Didn't I just give you two sides? Yeah. Caleb, do you remember which spot you have to be in to draw this thing?
Quadrant one.
Yes, whenever it's variables, you use quadrant 1. Also, Caleb, apparently this is your calculator. It was given to me after the ACT or something. I don't exactly understand. Was it from the ACT or was it?
Doesn't have any on it, yeah.
Makes it pretty clear. Okay, so we're in quadrant 1, and you're drawing a triangle, and this is the key central angle, aka the, starts with an R? Reference angle. So I refer to that one when I figure out adjacent, and where am I getting that from? Ka, so ka toa. This is ka. Okay, so adjacent over hypotenuse. So they gave me the adjacent side and the hypotenuse side. And this last side would be, I'm hoping you don't have to bust out a squared plus b squared equals c squared. You could just go square root. And then the longer side first, x plus 1 is clearly longer than x is, and it's the hypotenuse. Squared minus x squared. Now, could you simplify that down? Yes, you could, but let's not waste time doing that. And your final answer, cosine. Oh wait, I haven't ever asked a question. I just gave you a problem. My question will be, what's tangent of theta? And that's super easy. The hard part, setting it all up. So you really need to take lots of time drawing your little triangles, labeling your sides, be careful with negatives, figuring out what quadrants you're in. Because once this is done, it just comes down to so ka toa, and tangent is toa. So I need the opposite side over the adjacent side. So here's the opposite side, square root of, and could I multiply that out? Sure. And in fact, on the test, you probably would want to, but I'm just going to go like this for now to save time. Over adjacent, which is x, and there we go. Okay, so what else is left? Well, you have done a bajillion problems with sine, cosine, and tangent now. But did you know there's actually 6 functions? There's sine, cosine, and tangent. And then there are 3 more. So whenever we've been saying sine, we've been writing it this way, sine. Because it's a 3-letter abbreviation. Its word is actually sine. You didn't know that? Welcome to the truth. That's the function, sine. And then cosine is actually this. That's the word. Otherwise, it's just a 3-letter abbreviation. I think you all knew that tangent was not really tan, it was tangent. All right. So what are the other ones? Can anybody name one? Yes? Secant. And secant is going to go across from cosine. Now, just by using some logic, you can figure out the rest of them. Give me some logic. Bust out some logic. Anya?
Should I list one? Or
Is what?
should I list one?
Yeah, just tell me another one.
Cotangent?
So how did you use logic to figure out there must be a cotangent?
Well, sine has a cosine.
Exactly. If sine has a cosine, tangent must have a cotangent, and that goes across from tangent. Caleb? Exactly. Okay, so I call these sister functions, and because they're related, but they're not the same as each other. Okay, they're officially called reciprocals. And why does that matter? Well, because a reciprocal, if I had a number 5, do you know what the reciprocal of that is? 1/5. Yep. If I had a 2/3, do you know what the reciprocal of that is? 3/2. If you multiply reciprocals, Do you get how you get, they all cancel and it turns into a 1? If I multiply these reciprocals, it'd be 1. When you multiply reciprocals, you get 1. All right. So these are reciprocals of each other. So now underneath this, I'd like you to write this sine of, let's pick an angle, let's say it's 30 degrees. And has anybody memorized it? I told you to, because it would come up a jillion times, and this is one of those. Yes? That is, 30 is pi over 6, you're right, but not sine of 30. Sine of 30, Sam? 1/2. Everybody write that out. Now what we can do is go through and find all the other functions just from that one. If I know sine of 30 is 1/2, I can know all the other functions, because sine is the master function. Everything else just follows from sine. Okay, so I'm going to go down here for just a second and just show you what I mean. Here's sine. It does this, and it just keeps going in both directions forever. You know what cosine is? It's just shifted sine. Cosine is just sine, except it's been shifted over a notch. And I did not draw that correctly. Just a second here. That's where 2 pi is. So it goes like this, and then it just keeps on being exactly kind of like a counter to it, except it's just shifted a little bit. It's like the peak is here compared to the peak is there. All right, so sine, cosine, and tangent. Do you remember that tangent is just y divided by x, which is sine over cosine? So tangent is just made up. It's you take sine, you have to have sine, and then tangent is just sine over cosine. All right, so they all based on sine. Sine is the master function. And so when we write functions later, we're going to call them sinusoidal functions, because it's all based on sine. All right, so back to sine. So I have sine of 30. Then I'd like you to write cosine underneath it. Got this one?
That would be root 3 over 2.
Nice. Now, how did you get that? Well, I personally think you memorized the 30, 60, 90 triangle, you cheater. It's not like that's cheating. That's just smart. Because do you get cosine of 30 now is pretty easy if you have that triangle in your head? Cosine is root 3 over 2. I wouldn't have been able to just look at a half and say, well, obviously it's root 3 over 2. That's not going to work for me. But all right. And wait, while I still have that up there, what is tangent? Let's put it right here. Tangent of 30. Well, TOA, opposite over adjacent. Would you agree that 1 over root 3, but on a lot of times on the key, it's going to be root 3 over 3 because of rationalizing? Don't forget that. Okay, so there's my 3 functions that we already knew. Now over here next to them, write these in a different color. I'm going to choose, what am I going to choose? I'll choose black. Sine, this is going to be CSC. That's the 3-letter abbreviation for the word cosecant. CSC. Cosecant of 30. And I just took a while to explain that these were reciprocals, so 2 over 1. Sam L. I'll help you with what this is. It's secant. But can you tell me what it will be?
2 over 3.
Yep. And last but not least, Callie, can you finish off that last one? Cotangent of 30. Root 3 over 1. Could you just say root 3? Sure you could. But I will put over 1 just to emphasize the fact that it's flipping the other one over. Okay. Now, sine is the opposite over the hypotenuse. So what's cosecant? Yeah, hypotenuse over opposite. So if you're going to have a, SOHCAHTOA, then you could also have a CHO. And then this one is cosine is CA adjacent over hypotenuse. So this one's going to be hypotenuse over adjacent. SHA. And then TOA. So and Choshakao. Are you going to actually memorize that? Probably not. You're probably, well, this is kind of dumb. It's going to stick in some of your heads. But the bad part about Cho, Sha, Cow is that there's two C's. That kind of stinks. So you'd have to know that you start with cosecant to be able to make that work. So I am not endorsing Choshakao. I just thought it's kind of funny. So I actually endorse, if I'm going to try to find cosecant, I'm just going to go find sine and then flip it. So seriously, let's do a triangle. And let's do the 3690 again. Everybody make that one. It'll just take you 2 seconds if you know what you're doing. And then, if I asked you to find cosecant of 30 degrees, all you do is think back to that little chart I just gave you. And if you want a way to remember these, this is what works for me. Sine, cosine, and tangent, I already knew all of those, right? But the S goes with a C, and the C goes with an S. So every time you have an S, you have a C that goes with it. Or if you have a C that goes, you have an S that goes with it, okay? So C's and S's go together. I know that's not bulletproof because you might think that sine goes, you might get your C's confused because there's two C's, one's cosine and one's cosecant. So it's not bulletproof, but if you just want a way to remember which one's which, sine goes with S goes with C, and C goes with S. All right. And then tangent and cotangent actually sound like they should go together. So, okay. So back over to here. If you're going to find cosecant of 30, honestly, I wouldn't. I wouldn't find it directly. I would say, Mr. Server, I peacefully refuse. And instead, I am going to go find 1 over sine of 30. So I'd go figure out sine of 30, and I'm putting the 1 over to make sure you remember to flip it. You know what I mean? It's not just sine of 30. 1, 2, square root of 3. Sine of 30 is 1/2, but cosecant would be 1 over that 1/2, and so therefore it'd be 2. All right, well, we just did all the 30s. You had that on your chart. And we already knew that cosecant of 30 was 2. It says so right here. But I'd like to do the 60s now. So I'd like you to find secant of 60. And let's see how your brain thinks this through. Everybody figure out secant of 60. And in a minute, I'm going to ask you to explain what you did to the kid next to you to find secant of 60. Pausing. Okay. Sullivan, can you talk me through how did you do that?
It's 1 over cosine of 60.
So you just didn't figure out secant right away. You did 1 over cosine of 60. And cosine of 60 is what? 1/2. And so it's 1 over 1/2 again, which is 2 again. Raise your hand if you had 2. Okay, cool. See, these are really easy as long as you can keep track of which one is which, like which one's the flip of which. All right, so I shouldn't have to draw you anything for this. I should be able to just say, what's cotangent of 45? Peacefully refuse to do cotangent. And instead, do something else. I'll pause for a second. This time, just share the answer, not until you know they're ready. As soon as you know that they're ready, then share answers with the person next to you. So that one went really quick, and I think everybody just went and did tangent of 45, and then flipped it over. So don't forget to put 1 over. Otherwise, you're going to, by accident, just go figure out tangent of 45. So here's my 1, 1, root 2 triangle, and then TOA is opposite. I'm going to pick this 45 here. You could pick either one. But TOA is opposite over adjacent, and then that's 1, and then I flip it, and it's 1. Oh, that's weird. All right. So I want to take just a second to talk through that. Tangent and cotangent are called co-functions, you know, because one's got a co of the other. So what would be the other co-functions? Sine and cosine, and secant and cosecant. All right, just show you something. This is just a quick aside. Sine 30, cosine is 60. You ever noticed they're the same? How about what we just did was tangent of 45. And, oh wait, what was it again? 1, right? And cotangent of 45. See if you're picking up what I'm laying down here. I want you to figure out, if I said cos, no wait, not cosine. What's the other pair that's co-functions? Secant and cosecant, right? All right, secant to something. And cosecant, CSC. Anybody want to make a prediction about those two? You don't need, then it's only 2 of you see it. What's going on here? Yes, what would you predict?
Since all of these add up to 90, these pairs, then they both be the same.
Then they are the same. They both add up to 90. This and this add up to 90, then they're the same. So I can even give you a more ludicrous example. Sine of 5 degrees and cosine of, what do you think I'm going to say? 85 degrees, so they'll add up to 90. They're equal to each other. Whatever it is, they're equal. If the two angles add up to 90, those answers are going to equal each other. All right, so I want you to take a second and actually figure out what's secant to 30 and what's cosecant to 60. It'll be the same, but take a second, act like it's 2 separate problems, and just see that they do come out the same. So Lucas, if you're going to try to do secant, you got to immediately switch functions to, have you got it memorized yet?
Cosine?
Cosine is correct. So then you're going to find cosine of 30, and then you're going to flip it. So then here's my triangle. I'll help. This is the 30, 60, 1, 2, square root of 3. So you tell me what am I doing again to get this answer?
The secant of 30,
So instead of secant, we're going to do
cosine.
cosine of 30, but then it's not exactly the same as that. It's a 1 over that, right? Okay, so then what is 1 over cosine of 30? Well, what's cosine of 30?
Yeah, well, so it's 1 over square root 3 over 1. Wait, no, 2.
2. And then what does 1 over something mean? It means flip it. So then what's the answer? Flip this.
2 over square root 3.
2 over square root 3. There's your answer. And I bet you anything, when you figure out cosecant of 60, it's going to come out the same. Okay, so let's not just trust that though. Would everybody please figure out cosecant of 60? Matthew F., can you tell me? What are you're not doing cosecant probably, you're doing what? Sine of 60, and then you're gonna flip it. So how do I do sine of 60 again? There it is. Sine is opposite over hypotenuse. Root 3 over 2. Oh my gosh, it's gonna flip and it's gonna be 2 over root 3 again. Exact same thing as before. Look at that. So if these angles add up to 90 and you're using co-functions, then they'll be equal. All right. That's kind of just an observation, but it's kind of a cool one, I think. All right, let's go to slide 2. This is just a radians game. I'm going to make it super fast. Can you just tell me what pi over 6, pi over 3, and pi over 2, and pi over 4 are? Because those are the ones I want you to memorize. I didn't put them in order on purpose because I don't want you to just memorize them in order. So, pi over 2. Sam, what is it? 90 degrees. Good. Davis, what's pi over 6? 30 degrees. Do you have a way of remembering it, or is it just plain memorize?
Well, pi is 180.
Ah, so it's like 180 divided by 6 is 30. Very nice. Lucas, pi over 3?
45?
Nope. Pi over 4 is 45. Pi over 3? It's like 180 divided by 3. So 60. Have those memorized. Okay? Moving on. I don't want to take time to make you memorize the unit circle. If you choose to do that, cool. But I want you to be able to find any spot on the unit circle. So I'm going to ask you, if I gave you that angle, and I said, to me, that looks like a whole bunch of 60s. Can you please figure out what is that angle? In degrees and in radians. Everybody figure out what angle it is first. It's a whole bunch of 60s. I see a headphone in. Please take it out. I'm not saying who. You know yourself. All right, Sammy. A whole bunch of 60s. How many 60s?
4.
4 times 60?
240.
240 degrees. Raise your hand if you had that one right. Cool. And then if it's a whole bunch of 60s, there's a whole bunch of pi over 3s. How many pi over 3s? Well, right here it was 3 pi over 3. So then it must be just one more. So 4 pi over 3. Okay. And then I'd like you to just figure out, what would this spot be? Hint, it's just the triangle that goes with that. Would you please make the triangle and figure out what its sides and what its angles are? This is 60, Marcus. So then this is 30. What's across from the 30-degree angle over here? You got to memorize this. It's a 1. Right across from the 30 is a 1. Always. Across from the 30 is a 1. And then you go 2 square root of 3. 1, 2 square root of 3. And then what's the most common mistake at circle trig, Sammy? So what should be negative?
The 1 and the negative.
Good. Now, if this really is the unit circle, Davis, what do we divide everything by?
2.
Why did you choose 2?
Because you want the hypotenuse to be
We want that to be 1. Very good. So now, do you get I could put in these two things? Caleb, what are those two things in order? What comma what? Going over this far, and then down this far.
Yeah, sorry. 1 over 2.
Okay, negative 1 over 2 is the first one.
And
Negative 1 over 2 and negative root 3 over 2. And that was a lot of work, but now if you asked me what sine, cosine, or tangent would be, I could do it. But couldn't I have done it earlier? I could just use those blue sides to find sine, cosine, or tangent. Like sine from the 60s perspective is this blue number over this blue number, which is negative root 3. And sine, oh, sorry, sine is opposite over hypotenuse, sorry. It's this blue number over this blue number, which now is located, sine is y, right there. So I'm just showing you there's two ways to do it. Drawing the triangle is probably a little faster. Unless you've got them memorized, like you got them down, like you can just see it in your head. If you can visually see the unit circle in your head, then you might be able to answer these a little faster. But that won't help you when the radius is not 1. When the radius is not 1, you'll have to draw it. And we practiced that already. All right, we've already practiced a bunch like this, so we're going to move on. And we already practiced one like this, but I think we could just do one more. Everybody try that one right there. Number 21. Typical test question. I'll pause, we give that a shot. It comes out to 24. Because the 7, 24, 25. I'm curious how many of you remembered it. Okay. There's not too many of these. These are called Pythagorean triples. The 3, 4, 5 you learned a long time ago. There's one more I'd want you to have memorized. 5. You don't know? Yes? 5, 12, 13. Very good. These are the 3 biggies. There is one more that somebody found the other day, but I just haven't seen that one come up as much. So, and of course, doubling all of these, like 3, 4, 5 doubles to 6, 8, 10. That's also good, but it's really just a 3, 4, 5 in disguise. All right, so I've made this in quadrant 4. I'm going to do it really quick. I always make mine kind of blocky triangles that look like I could believe their angles or whatever I say they are. And sine is opposite from this angle's perspective, the central angle, opposite over hypotenuse. And then this must be 24 because I have that one memorized. Otherwise, if I didn't have it memorized, you go square root of 25 squared is 625 minus 7 squared is 49, and you would have ended up getting 24. Okay, and then what's cosine? Well, from there, isn't cosine super easy? Cosine, adjacent, over hypotenuse, boom, 24 over 25. So once you get the triangles around, these are so easy. All right, let's move on. I just taught you these a second ago, but these are shuffled. Is cosine really equal to secant? Not equal, no, but are they sisters of each other? Cosine and secant? Yes, they are. S and C, remember? S and C and C and S. And sine and cosecant, are those really sister functions? Yes, they are. And so then, if I told you one of these things, like if I told you this, cosine of this angle is, let's say that's a 1 and that's a 3. To me, it looks like it could be a 1 to 3 ratio. Then you could be asked to figure out all the rest of them. Cosine is 1/3. Would you please figure out all the rest of them? The third side has got to come quickly by now. Square root 9, 1, not the longest side, so I subtract square root of 8. Up, simplify, root 4, root 2, 2 root 2. Who had 2 root 2 before I said it? Cool. Okay, then for the secant, I can just flip it. 3 over 1, done. For the sine, I have to go back to my triangle and go opposite. This side here is the opposite from the reference angle. Opposite over hypotenuse. So 2 root 2 over 3. Cosecant, just flip it. 3 over 2 root 2. And tangent, TOA, opposite over adjacent. That's the opposite. That's the adjacent. So 2 root 2 over 1. And this is 1 over 2 root 2. See, these are really not that hard, as long as you know which one's which. So if I say cosecant of something, of, let's say it's 45. This won't be hard at all, except if you don't remember which one that goes with. Which one does cosecant go with? You're gonna replace that with 1 over sine. And sine of 45 is easy, and then 1 over it just means flip it. Okay. Get to this page. This is where they officially say which are all of them that go together. Secant is 1 over cosine. That's what we were saying the whole time. Cosecant is 1 over sine. All right. And here are the problems that I would highly recommend. These should be literally 15-second problems. You should be able to go, oh, pi over 4. That's 45 degrees. I'm going to draw my 45, 45, 90, 1, 1, root 2. I'm going to say that's 45. And if I want tangent of that, it's TOA, opposite over adjacent. These should go like super fast. All right, so do all of those on that page. Then on this page, they have circled certain ones, so let's cross off everything that isn't circled. And this one's a little too easy. Cross that one off too. So just do those 3. And on this page, remember the challenges you can always skip, so we can cross those off. Now, this one might feel messed up because they're giving you cotangent to start with, and they only give you one side. Would you agree that then you could always just put it over 1, and now you've got 2 sides? And you might be like, I don't know how to draw cotangent. Well, then don't draw cotangent. What are you going to draw this for? Come on, who can translate this into something that we just knew yesterday was easy? Tangent of theta would be 1 over root 5. So that's really what they just told you. And it's in quadrant 3, so now it's not hard to draw. Okay, so you always got to take your weird new functions and translate them in your head to their sister function. And then, of course, flip it. All right, so I think you should do, why don't we just do that one? That'd be enough. All right, if you do those things, you will be in good shape. Now, do you get that we could have tested you on Monday? So the test is near. Okay, so tomorrow is a review day. And then Monday could have been the test, but because it's a Monday, we'll be super overly, generous with time. But this is the part where I said I'd give you those tests back from yesterday if you wanted to look at it. So work on this homework or ask me for that test back to look at it. You don't have to, but if you want to see it, I'll happily hand it back to you. So we really should be ready for this test on Tuesday because it could have come on Monday. That's all I got for you for the video for today.